Assalamu alaikum. I am Asiafin Alo. The last four digit of my ID is 1567. Today, me and my teammates are presenting about the software requirement specification for the e-ticketing system. The purpose of our SRS is defines complete functional and non-functional requirements for the e-ticketing system. It acts as the main reference documents for all stakeholders, developers, testers, project managers, administrators, and clients, so that everyone shares a unified understanding of what the system will deliver. It covers all modules, passenger portal, admin console, and operation interface. All requirements are labeled sequentially, such as requirement 1, requirement 2, and each requirement is assigned a priority level high, medium, or low. Technical terms and abbreviations are explained in the glossary to avoid confusion. The system scope includes providing an online platform where passengers can share for transport options, select seats, make secure payments, and download or manage their tickets. For administrators, the system offers full control over routes, schedules, and user accounts. Operations will be able to verify tickets digitality, improving efficiency and reducing fraud. Then the overall description of our project. Our project perspective is web-based standalone system replacing management. It integrates directly with the SSL payment gateway and use Google Maps APIs for real-time location feature. Our product feature is passenger, operator, and admin. Passengers use the simple, intuitive interface, while administrator requires more technical control over system configuration. Operator use the system mainly for fast and reliable ticket. There are three user classes: passengers, admins, and operators. Operating environment. The environment must follow specific constraints including React.js for the front-end Laravel or Node.js. Accessible on desktop, mobile, tablet, supports Chrome, Firefox, Safari, requires a stable internet connection. Thank you everyone. That's all about my presentation. Now I invite my next teammate Dipani Tapal to proceed.
Hello everyone. Today I am excited to present to you the complete design and workflow of our e-ticketing system. My name is Dipanita Pal, ID 1509, and I will be walking you through how this system is built and how it works from start to finish. The front end is built with React.js, which makes the user interface fast and interactive. The backend can be built using either PHP with Laravel or Node.js with Express. We use MySQL as our database and all communication happens through a REST API. Everything runs on the Ubuntu server for stability and performance. Security is a top priority. We use bcrypt for safe password storage, TLS 1.3 for encrypted data transmission, and an account lock feature after 5 failed login attempts. For added safety, users are automatically logged out after 30 minutes in interactivity. Our system integrates with SSL Commerce for secure and reliable payment processing. We also use Google Maps for real time vehicle tracking, so passengers and operators can see exactly where their bus or train is. This system is built for performance is can handle over 10,000 users at the same time, is fully mobile responsive, and support both Bengali and English language to make it accessible to more people. Here's the simple step-by-step flow for users. First, they search for a trip, then select their seats, log in or register, verify their emails, make the payment, receives their e-ticket, and finally they can manage their bookings. Our system serves three main users groups. Passengers can register, search for trips, book seats, pay and manage their tickets. Administrators can manage users, set up routes and view reports. Operators can verify tickets using QR codes and track vehicles in real time. Key rules of login. Strong password required, must verify email before first login. Account looks after 5 wrong tries. auto logout after 30 minutes. The flow is register, then Gmail, then verify, and lastly login. To keep account safe, we enforce strong password with 8 plus characters including letters and numbers. Users must verify their emails before logging in for the first time. After 5 wrong login attempts, the account is locked. And there's an auto logout after 30 minutes of initiativity. The flow is very simple: register, receive email, verify, and then login. Booking a ticket is simple 4-step process. First, search by choosing your vehicle, type, route, and date to see available trips and prices. Then login. This is required before you can pay. Next, select your seats from the live seat map. Green means available and seats booked temporarily one selected. Finally, pay and confirm security through SSL Commerce and you will receive a PDF tickets with unique QR codes. Now the functional requirements. To wrap up, here are the key things our system must do. It supports account with sign up, login and password reset. Users can search for tickets without login. The seat selection shows a live map and prevents double booking. Payments are secure via SL Commerce. Tickets are generated as downloadable and PDF with a unique QR code. And finally, users can manage their bookings, view history, and cancel trips if needed. Thank you, sir. Now, our next team member, Salman Hauladar, will present the next slides.
Assalamu alaikum everyone. I am MD Salman Hauladar. Last 4 digit of my ID is 1105. Today I will present the external interface requirement of our e-ticketing system. This section explains how the system interacts with users, hardware, external software services and communication channels. User interface. Our system includes 3 main user interfaces. The passenger web interface offers a responsive and bilingual experience. The admin dashboard includes tools for managing routes, users and reports. That operator mobile interface focuses on fast QR verification and works even when offline. Hardware interface. This system interacts with various hardware devices. Passengers use smartphones or computers. Operators use QR scanners for ticket validation. Thermal printers support printed ticket options. On the back end, service use SSD and high-speed networking to ensure performance. Software interfaces. The system integrates with several external software services such as MySQL for data storage, SSL Commerce for payment processing, SendGrid for emails and Google Maps for location. All these connections use secure REST API and JSON data formatting. Communication interfaces. For communication, the system uses HTTPS for all above interactions. REST APIs handle data exchange while real-life features use WebSockets. Emails rely on SMTP and SMS alerts use secure APIs. All external communication is protected using token-based authorization. Thank you everyone.
Assalamu alaikum sir. I am Sharmila Akhtar Sharna. Last 4 digit of my ID is 1042. And today I will presenting the non-functional requirements for our e-ticketing system. These are the system qualities that define how well the system will perform, its speed, security, reliability and overall usability. I will be covering 4 key areas. Performance. Fast response time. Page load under 3 seconds, payments processed in 2 to 5 seconds, and ticket scanning completes in less than 1 second. High uptime. The system maintains 99.5% availability during operating hours to ensure continuous service. Effective resource use. Server CPU stays below 80% and memory below 100% concurrent users during peak time. Security. Strong access control. User password policies optional 2FA and role-based permission to ensure only authorized access. Encryption everyone. Implements TLS 1.3 for data in transit and AES 256 for data at rest, protecting all sensitive information. Protective defense conducts regular security audits and ensures detection to prevent and response to threats. Productivity. Data safety encrypts all personal and financial information to prevent unauthorized access and breaches. Operational safety prevents duplicate booking and designs interface to minimize operator distraction in vehicles. Forward prevention includes safe against ticket scalping and fake bookings to protect system integrity. Emergency readless makes emergency contacts and conclusion policies easily accessible in case of dispersion. Software quality reliable ensure 99.9% transaction accuracy, making the system trustworthy or for users. Usable offers a mobile responsive interactive interface that requires no training to use. Maintainable and scalable built with modular code to easy updates and handle 50% user growth. Robust and interruptible recovers automatically from minor failure and integrates well with existing transport system. Use case diagram. This use case diagram gives us complete overview of our e-ticketing system functionality through three key perspectives. First, for passengers, the journey is straightforward. They log in, search for routes with filters, select their trip and seats, and complete payment. They can also manage their existing booking by view history and scanning tickets. Second, our operators handle real-time operation. Their main tasks are verifying ticket checkpoint and updating vehicles location for live tracking. Finally, administrator maintains system control. They manage user accounts, approve or reject transportation schedules, and monitor overall system activity. The include arrow shows essential steps like password verification during login. The extend arrows indicate optional scenarios such as when ticket verification happens after booking or when certain user management action might be restricted. This visual clearly separates responsibilities and shows how each user roles interacts with our platform's core feature. Thank you, sir. Our next slide will describe Ashfaquzzaman Shihab.
Good day everyone. I'm Muhammad Ashfaquzzaman Shihab and the last four digits of my ID are 1666. Today I am going to explain two important diagrams from our e-ticketing system, the activity diagram and the sequence diagram. Let's start with the activity diagram. When a user opens our e-ticketing website, they choose a vehicle type like bus, train or plane. Let's say they choose bus. The system searches for available tickets and displays the seats. The user selects their preferred seats and click book ticket. Then the system checks if the user is logged in. If not, they either register with email verification or logged in with the existing account. Right after the user proceeds to payment through our secure partner, if payment is successful, the system automatically creates a PDF ticket, sends a confirmation message and allows the users to download it. The database is updated in the background, completing the process. Now let's see the sequence diagram. The diagram shows that the main parts work together, which are the user, the system interface, the database, the payment gateway and email service. When a user searches for tickets, the system receives the search request and asks the database to check what's available. The database sends back the result and the system displays them to the user. When a user registers an account, the system saves their data to the database, then sends a verification mail. The user clicks the verification link. The system updates their status to verified in the database and shows a confirmation message. While login, the user enters their credentials. The system checks these credentials with the database. If valid, the database confirms and the system shows login successful to the user. While booking, the user selects a route and date. The system gets available seats from the database and displays the seat layout. After the user selects a seat, system reserves it in the database and sends back a confirmation showing reservation successful. While the user wants to buy a ticket, the system needs payment details to the payment gateway. The gateway processes the payment and responds with success or failure. If success, the system updates the booking in the database, then generates and shows the ticket to users. The diagram also covers features like track vehicles, where system gets GPS data from database and shows it on a map. Cancel tickets, where system updates database, processes refunds through payment gateway, then sends email confirmation. Reschedule ticket, where system checks database for new options, user selects, system updates and sends new tickets. Forget password, where system creates reset links, sends via email and updates database with new password. So to summarize, the activity diagram shows the complete journey of booking a ticket step by step, while the sequence diagram shows how all the different parts of our system communicate with each other to make that journey happen smoothly. Thank you for your attention.